All right. Now, good day, by the way. Right. Now we will cap off this little topic by discussing the adjoint and the inverse. Right? And you might say to yourself, okay, what is an adjoint? What is an inverse? The inverse one, maybe you can kind of guess what it is from the word itself, but these two, right? I will check them off right now so that we can have this whole checklist done, right? These two are now very involved in the and answering the question. But well, say for example, if A and B are the same size, you can add A and B, right? You can subtract A and B. You can of course multiply A and B, but can you divide A and B, right? So now the answer is no, right? You cannot do that. But the easiest way, or rather the easiest kind of alternative, is for you to take, right, the inverse of b, which is denoted by b raised to negative 1. So very interesting, right? It's kind of the same thing as doing a over b, but it's not possible, of course, for matrices, right? So this is the oh, what do you call this? This is the closest thing that we have. And so now, right, we will first start off with the adjoint. The adjoint of a function is basically, say for example, we have a in here. The adjoint of a, right, which you would, oops, yes, code. You want to go up? Okay, whatever you say. Where are we? Okay, there you go. The adjoint of a, right? The adjoint of a is such that you will create the cofactor matrix of a. Oops. Cofactor matrix of a, and then you transpose it. So you're like, huh? Cofactor matrix? Yes, a cofactor matrix. So say for example, we have here A is a simple 2 by 2 matrix. A, B, C, and D. We will come back to our cofactor, right? So basically, for us to create a cofactor matrix of A, we will have to do the thing that we were doing earlier, which is, right, in creating, or rather in computing for the determinant, you are doing this, and you are excluding everything else on that row and column, and you will compute the determinant of what remains. So in this case, D is what remains. So the cofactor of A at that specific point, right, at that specific point is going to be D. Okay, and mind you, right, there is still an underlying sign in here, right? Because this is the first row, first column, 1 plus 1 is 2. That is an even number, so this is a plus, right? The other one's minus, minus, plus. So let's remember this thing, okay? Now, we have the cofactor for the first row, second column. This one is now a negative. We know that for sure, and that is going to be negative C. Negative C. This one is now second row, first column, cancel, cancel. This is still also negative. And what remains is B. And then finally, we have second row, second column. That is going to be a positive. And what remains is A, right? And so we can see here that that is the cofactor matrix of A. Sorry, this should be letter A. It seems simple, and now we just transpose it. We now get the adjoint of matrix A, which is going to be the transposition of your cofactor matrix, which makes this, right? If you do this, you just switch the values of negative B and negative C, and well, there you go, right? And then we have here D and A. We're just going to switch negative C, negative B. This is your adjoint of A. And now, I have a couple of questions for this. What is going to be the determinant, or rather, what is going to be your value for A times adjoint A? Let's try that out now. If this is your A, this is your adjoint A, let's try and just get in here, right? What is, ouch, ouch. Sige, bababa ka ba? Okay, you're not. Sige. So we will have A times adjoint A, right? We will have here basically A, okay, so bumaba nga siya. A, B, C, and D. And then here we have the adjoint B, D, negative B, negative C, and then A. And we'll just have in here our piecewise multiplication again. Right? First row, first column, first row, first column. That will be AD minus BC. Where have I heard of that before? Right? Next, first row, second column. First row, second column. A times negative B, negative AB. B times A is AB. So that's a 0. Okay. Next, second row, first column. Second row, first column. C times D, CD. D times negative C, negative CD. So if you add them together, they become 0. And then, this one, the last one. The last one. Second row, second column. BC, or right, negative BC. And then DA. We have another AD minus BC. And if you notice in here, we can actually factor out the AD and the BC. AD and BC. Where have I heard of that before? That is actually going to be the determinant of your original function, right? A, B, C, D, right? AD and then BC. That is the determinant of your original. And look at this. This is basically your I, right? This is your unit matrix. This is a 2 by 2 unit matrix. So that means that A times adjoint of A, right? A times adjoint of A gives you the determinant of A times I. Why is this so important? This is the adjoint. Basically, the adjoint of A is basically the matrix that is able to create this whole computation. And why is this so important for an inverse? Well, I will have to ask you guys first. What is the reciprocal of 3? Oh, you can just say it's 1/3. Right? What is the additive inverse of 3? Negative 3, right? It's just a negative. Right? So we are now talking about the multiplicative inverse, 1/3. Basically, why are you so sure that this is the reciprocal of 1/3? It's because if you multiply these things together, you will create the multiplicative identity 1. Right? So basically, if you are saying A over B, what you're saying in here is you are multiplying the first number by the multiplicative inverse of the second number. Why am I being so technical? Why am I being so languagey or legal languagey over this? It's because this is important. Now, if we're going to generalize this in terms of matrices, right? There is no way that we can do something like this. That is not allowed. However, we can do A times the inverse of B. But we need to know, or rather, we need to understand what the inverse of B means. If we said before that 3 times the inverse of 3 is your multiplicative identity, that must mean that B, right? That in this case, B times the multiplicative inverse B inverse should be equal to 1. But not in this case because these are matrices. What is the multiplicative identity matrix? That is your unit matrix, which is here already. Look at this. A, right, times blah, blah, blah is I. And what's better is that this determinant of A is just a number. We can do number things with that. In other words, we can divide both sides by the determinant of A, and now you will see A times the adjoint of A divided by the divided by the determinant of A creates this very unique I. Now we can finally, right? We can finally define, right? We can finally define the inverse of A inverse as going to be the adjoint of A divided by the determinant of A. And so now basically, if you have, right, an A which is A, B, C, and D, your adjoint, or rather your what do you call this? Your inverse of A will now follow adjoint A over determinant A. In this case, we remember our determinant in here is just AD BC. AD minus BC pala rather. AD minus BC. And our adjoint was just the transposed cofactor D. A, negative B, negative C. And so, right, if you want, right, we can just factor this is a scalar, by the way. This is just a number, right? So we can just put it all inside, right? We will have D over A minus AD minus BC, negative C over, I mean, you can do this over and over again, but suffice to say, this is the inverse to every 2 by 2 matrix that we have available, right? Okay, so that is the inverse for all 2 by 2 matrices. Okay, whatever, right? What is this used for? Well, we'll find out, right? But that is the what do you call this? That is how we get to the definition of the inverse. So let's try it out, right? Let's try it out for a 2 by 2 and a 3 by 3 matrix. Okay, let's try R, right? We haven't used R before, right? Matrix R. Let's say, for example, this is, I don't know, 5, 4, 3, and then -1. Okay, for me to create R inverse, how will that happen, right? Again, if you guys have a calculator beside you, I understand. You can get your inverse very, very easily, right? And I think some calculators, if you say divided by matrix A, matrix B, whatever, they can kind of interpret it as the inverse, but I want to know how it's done. I don't care about the results necessarily. So this means, right, in your exam, I'm looking at the solution, not the answer necessarily, because again, if this exam will be online, more often than not, you will be able to just like put it in a calculator and that's done. What I want to see in here is you understand the process going into this thing. Okay, so what is going to be our R inverse? That needs to be the adjoint of R divided by the determinant of R. The determinant, very easy to find, right? We can just do this mentally. 5 times -1, -5, minus 3 times 4 is 12, so that's -17. So this is going to be a very yucky, right? This is going to be a very yucky inverse, okay? So R raised to -1, we need now the adjoint of R, which is the transposed cofactor matrix. Cofactor matrix. There you go. So let's try out the cofactors in here, right? So we will have first row, first column, -1. First row, first column, 1, 1. That will create an even number, so -1, right? Same goes for this one, right? Second row, second column, you will just get 5. And honestly, there's a whole pattern to this, right? If you remember, right, what happened lang with the adjoint is that you just switched the places of these two things and you just put on negative values for B and C. So if you've detected that, good job. You can use that again and again, right? So basically in here, what you will have is -4 and -3, right? So there you go. That is already your adjoint. And that means your R inverse will just be this thing divided by, right, -17. So -1, -4, -3, and then 5. We will have in here +1 over 17, +4 over 17, +3 over 17, and -5 over 17. So you might say to yourself, ew, that looks disgusting. Well, let's try and find out if it does indeed give us our 1 or our unit matrix. So we're still not sure, right? Let's try and see now. Your R is, what was that thing? 5, 4, 5, 4, 3, -1. And then we will have this thing, 1 over 17, 4 over 17, 3 over 17, and then -5 over 17. Let's try this out. We will have first row, first column, first row, first column. 5 times 1 over 17, 5 over 17. 4 times 3 over 17, that is 12 over 17. 5 over 17 plus 12 over 17 is 17 over 17, which is just 1. Okay, right? First row, second column. First row, second column. We now see 5, 4, 20. 4, negative 5, negative 20. Both of them are over 17, which does not matter. 0. Looking good so far. We now have second row, first column. Second row, first column. 3 times 1, negative 1 times 3. Even though they are over 17, they will still be 0. Last bit. Second row, second column. Second row, second column. 3 times 4 is 12. Right? And the negative 1, negative 5 is 5. 12 plus 5 is 17. Divided by 17 is 1. So that is indeed correct. And so, you can also try out, of course, right? What if it's now R inverse times R? What will happen then? Right? If you think about it, the inverse of R inverse is R. Right? You inverse it again, you will just get R. So in this case, right, we said before that A, B is not commutative with BA. However, there are times that this is true. The times that this is true would be for a matrix and its inverse. Okay? For matrix and its inverse. Now, the thing that is more difficult, of course, is what if you have a 3 by 3 matrix, right? What is the runtime so far? It is 17 minutes. We still have, what is the, could not access the specified, yeah. Okay, so we're good. We're still good. Now, let's say, for example, what have I not used yet? I don't want to use matrix O. And group PQ. L, K, J, I. I is reserved. G, F. I'm so sorry. I'm getting hung up over this. W? Ew, V na lang, V. V. How do I do the V? There you go. V. And now, let's just have a very small 102. I don't know. Negative 1, negative 1, 3. I don't want to give myself very difficult values. 2, no, not 0. 1, 1. Okay, let's have something like that. What is going to be our V inverse? Okay, it's going to be our V inverse. First, we can calculate our value for the determinant of V, right? 1, negative 1, and 1, that is 1. 0, 3, and 2, I'm not going to bother. Negative 1, 1, and 2, that is minus 2. And then we go on to our upward diagonals. 2, negative 1, and 2, that is now positive 4 because there is already a negative in here. 1, 3, 1, that is minus 3. And 0, negative 1, and 1, I'm not going to bother. And in this case, there is no, there is no, what do you call this? There's no determinant. So that means that there is no inverse. Sad, right? Okay, sure. Okay, let's try again. What if 2? Okay, let's try this again. What if 2? Let's try this again. Negative 1, negative 1, and 2, negative 2 this time. 0, 3, and 2, not gonna bother. 2, negative 1, and 1, that is negative 2 again. Did I miss something? No. Right? Next, upward diagonals. 2, negative 1, and 2. That is now positive 4 because of the negative. 0, 1, 2. I'm not going to bother. 1, 1, and 3. Finally, there you go. Negative 2, positive 4, and then negative 3. Our determinant in here is negative 3. Okay. Now, let's try out and get the adjoint. So this one is now going to be a bit more difficult because we have yet to see, right, the cofactor matrix, right, of V, right? And then, of course, we're going to have to transpose, but, right, if we're thinking of the transposition, that's going to be easy, right? And for the people who want the sign chart, it's plus, minus, plus, negative, positive, negative, and so on and so forth. Okay, that is our sign chart. Okay, we will have first the cofactor for this thing. There you go. We will solve for the determinant of this thing. Hopefully, you guys can mental this already. Negative 1 and 2 is negative 2. And then minus 3, that will be negative 5. Okay. All right, we keep going. This thing now. What is the determinant for this matrix? Negative 1, 2, negative 2, negative 1, 2. And then we have 2, 3 in here, which is 6. So minus 6. Negative 2 minus 6, that is negative 8. But because there's a negative in here, this will become positive. Positive 8. Next, we do this thing. Okay. And then we will have the what do you call this thing? The minor, right? The minor is negative 1, 1, negative 1. 2 minus 1, 2 negative 1 is negative 2, but that is made positive because of the determinant, right? So negative 1 plus 2 is 1, and there is a positive sign in here, so that remains a plus 1. Of course, I'm doing this all in my head, which makes it a bit more difficult. This one, what is the integral tuloy? Oh my gosh. What is the determinant for this thing, right? 0, 2, doesn't matter. 2, 1, that is now negative 2. But because there is a sign of negative in here, this will actually be positive 2. And then this one I feel like is the most difficult to look at, right? What is the determinant of this, 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 and this, right? You will now have 1 and 2 in here, so that is 2. 2 and 2, which is 4, negative 4. So 2 minus 4 is negative 2. Because of the plus sign, this will remain as negative 2. And we will go on and on, right? So just please bear with me for a few more moments. We will have this. The determinant of this is 1 minus 0, which is just 1. But because there's a negative sign, it's now negative 1. And then here, right? We will have this determinant right here, 0, 3, 0. 2, negative 1 is negative 2, but there's a negative sign. So positive 2, because this is a positive sign, this will remain a positive 2. And then we have just 2 more left. This thing, right? We will now have this. 1 times 3 is 3. 2 times negative 1 is negative 2. 3 minus negative 2 is 5. Because of this negative, this will be negative 5. Right? And then last bit, right? This thing. Okay? We'll now have 1, negative 1, negative 1, just negative 1. Right? Because of the plus sign in here, that will remain as negative 1. And I just want to double check, right? I doubted this thing for a little bit. 1, 3, 3. 2, negative 1, negative 2. 3 minus negative 2 is 5. But because of the negative sign, it is negative 5. Okay. So now this is our adjoint, our cofactor matrix. We have to transpose this. So along our main diagonal, we will keep everything the same. Right? So negative 5, negative 2, negative 1. But we will switch on everything over. Negative 5, 8, 1. And then this one is now 2, negative 2, negative 1. And then we will have 2 and then a 5 in here. So that is now our adjoint. Therefore, our V inverse is going to be equal to, right, adjoint over determinant. Our determinant is negative 3. So we will multiply by negative 1/3, negative 5, 2, 2. 8, negative 2, negative 5, 1, negative 1, negative 1, which means our matrix is going to be large. 5 over 3, negative 2/3, negative 2/3. And we will have negative 8 over 3. We will have 2/3, 5/3. We will have negative 1/3, 1/3, and 1/3. Okay, the final test is, honestly, I feel like you guys will just skip a little bit for this, right? What if you multiply your V and your V inverse? You know what? There is an easier way to do this, and that is using our calculator, right? So mode 7, I'll create a new matrix in here. 1, 0, 2, negative 1, negative 1, 3, 2, 1, 2. I will now ask the calculator what is the inverse, right? Just to see if we got it right, right? Inverse of matrix A. The inverse of matrix A is, right, 5 over 3. Okay, so let me see if I'm getting this right. 5 over 3, negative 2/3, negative 2/3. What is this? Negative 8 over 3? Yeah, negative 8 over 3, 2/3, 5/3, and negative 1/3, 1/3, and 1/3. So there. That is the handmade way to do this thing. Okay? So I'm not requesting that you guys do the very tedious thing, which, a computer can easily do. Right? I'm just asking that you be able to understand why the answer is like that. Right? So say, for example, I might just ask you, okay, can you do the cofactor for this thing? And can you get the blah, 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 blah? Okay? So something like that. Right? So now that is the adjoint and the inverse. So you might say to yourself, okay, very interesting. Wow, we can do matrix division, quote unquote. So what? The so what will be the application. So we will have two applications in here. First, right, we'll be solving simultaneous equations. And then second, solving simultaneous differential equations. So those are going to be two separate videos. Just please watch them. Okay? So thank you very much. I will see you in the next one.